Now we will see about the types of reactions. So mainly in this chapter there are two types of chemical reaction you have to understand. One is called metathesis, which is called exchange reaction, and second is reduction or oxidation reaction. So in case of metathesis or exchange reaction, the definition of this reaction in which cations and anions appear to exchange partners. So when cations means positive ions and anions means negative ion, when they change and they exchange their other half partner of ions, that type of reactions is called metathesis reaction. For an example, acid base reactions and precipitation reactions. So acid base reaction is also called neutralization reaction, in which acid and bases react to form water and salt. So when acid, for an example, we will see some more example in the other slide, but here is like HCl when react either sodium hydroxide. So this sodium hydroxide is a base and HCl is an acid. When they react together, they form sodium chloride plus water, H2O. So this sodium chloride is a salt and water. And next reaction is precipitation reaction, in which cations and anions come together to form an insoluble ionic compound. So when something is formed in the reaction and that precipitate in the reaction, so that type of reaction is called precipitation reaction. Next is reduction and oxidation reaction, in which electrons are transferred from one reactant to another. So mostly in metathesis reaction we will understand how the anions and cations are participating, and in the oxidation and reduction reaction we will see how the electrons are transferring from one reactant to another. So let's see some example for the acid and base reactions. So as we know that the best example is sodium chloride and sodium hydroxide. So when sodium hydroxide dissolve in water, it forms sodium ion and hydroxide ion, and when HCl dissolve in water, it forms hydrogen ion and chloride ion. So when they react together, so according to acid base reaction definition, the anions and cations, they exchange their partners. So sodium ion, right now it is with hydroxide ion, will change to chloride ion, and here hydrogen is with chloride, it will go with hydroxide ion with the other anion from the base. So then it will form H2O, which is water. H is written, and because this is showing that hydroxyl ion is going with the hydrogen ion, and then sodium chloride, salt. So neutralization reaction occur when acid and bases react together and both the hydrogen ion and hydroxide ion concentration decreases in this reaction. Next example is this neutralization reaction. We have seen many medicine on the counter for antacids, right? Alka-Seltz, X and Tums, and some magnesium, milk of magnesia also. So they are all have some kind of bases that reduces acid in our stomach. So some common antacids are, and what are the chemical inside? So like Alka-Seltz have sodium bicarbonate, Amphozel have aluminum hydroxide, Digel have magnesium hydroxide and calcium carbonate, milk of magnesia is magnesium hydroxide. So they are mild base which have some special formula in the form of medicine. When we have acidity or extra acid in our stomach, or we have kind of heartburn, we use these of acids to neutralizes, and we use these base mild base to neutralize our acid in the stomach. So these were the example for the some more common acid base for reaction. And then we have seen and we have studied in the electrolyte that most of the salts are strong electrolyte. So in case of neutralization reaction, when we know that we form sodium, when sodium hydroxide react with the HCl, it forms sodium chloride and water. So sodium hydroxide is sodium chloride is a salt. So most of the salt are strong electrolyte and most acids are weak electrolyte. However, HCl, HBr, HI, hydrogen iodic acid, nitric acid, sulfuric acid, chloric acid and perchloric acid are strong acids and strong electrolytes. So these are the only these acids are strong acid and strong electrolytes. So you have to just consider the salt are always strong electrolyte and strong acids are strong electrolyte. Common strong bases are the hydroxides of the alkali metal and the heavy alkaline metals. So lithium hydroxide, sodium hydroxide, magnesium hydroxide, calcium hydroxide, so they are the strong base. So all the metal ion from the alkali metal and alkaline earth metal, you may remember in the periodic table first two column from the left, first column is called alkali metal and second column is called alkaline earth metal. So metals from those, and when they make the base, they make usually strong base. And ammonia, however, ammonia is a very weak electrolyte because it is a weak base, and most other substances are not non-electrolyte. So if we talk about the strong electrolyte and weak electrolyte, we have to consider this point that most of the salts are strong electrolyte and most strong acids are the weak, but some acids are strong acid and they are strong electrolyte as well as. And on the other hand, some common strong bases also serve as a strong electrolyte, and ammonia is considered as a weak electrolyte. So this was about the example and electrolyte from the acid base. So here is some more example about for an example, if we have sodium hydroxide, which is a strong base because it is coming from the alkali metal, and if it is a strong acid base, salt or molecular, so this is a ionic compound which is based on metal and non-metals, and it is an acid, it is a base, and it is a strong electrolyte. Magnesium bromide is a salt because one is metal and another is non-metal, again ionic compound, and because it is not giving hydrogen ion or hydroxide ion, that is why it is salt, and it is from alkaline earth metal, that is why it is a strong electrolyte. Nitric acid is also a strong electrolyte. Methanol is a molecular compound. There is no salt, there is no metal, remember. Don't be confused with OH of methanol and sodium hydroxide OH. They are totally different. And this is a molecular compound and it is a non-electrolyte. Hydrofluoric acid is a weak electrolyte because this acid is also weak. So these were the example about the acid base reaction and how to categorize those acid, base and salts into strong electrolyte or weak electrolytes. Next we will see about the precipitation reactions. So next reaction is precipitation reaction, and according to definition that in the precipitation reaction one of the salt will not dissolve in the reaction and it will precipitate at the bottom. So you can see this an example here. When potassium iodide, when dissolved in the water, this beaker contain potassium iodide K and I, and another beaker have lead nitrate. So when potassium iodide solution dissolved in water and added into lead nitrate, it start forming a yellow color precipitate. So basically what happened here, potassium iodide in aqueous plus lead nitrate in aqueous, when react it form lead iodide and 2 Ki potassium iodide. So and also nitrate ion form. So nitrate ion form they will dissolve in the water. So only lead iodide is written as a solid. So you can see this is a yellow color precipitate at the bottom, which is represented as a lead iodide. So this is example of precipitation reaction, and let's see what happened in the metathesis reaction or precipitation reaction. When any precipitation reaction happen, the anion and cation also exchange. So AX plus BY equal to AY and BX. So when we added potassium iodide solution into lead nitrate in water, so potassium nitrate will form and lead iodide will form. So lead iodide will not dissolve in the water, so it will precipitate, and potassium nitrate will still remain soluble in the form of ions in the water. So this reaction is example as a, you can simulate like A, if A will be lead ion and X will be nitrate, so B will be potassium ion and Y will be iodide ion. So this was the example of the precipitation reaction, and let's see what are the driving force for these type of reaction. When a product of a reaction which remove ion from the solution, then this kind of reaction are happen. So formation of a solid which will precipitate at the bottom. If any gas is forming in the reaction, which will remove from the solution, and if any formation of a weak electrolyte or any formation of non-electrolyte. So these are the 4 driving force for this type of reaction. And then metathesis reaction or precipitation reaction occur. So in this example we have seen that the driving force for this reaction is precipitation of lead iodide. So lead iodide is removing from the solution, that is why this reaction is moving forward as much as. Next is the solubility rule. So how we will know which compound will dissolve in the water or not, and which will dissolve, which will not. So solubility of a substance at a given temperature is the amount of substance that can be dissolved in a given quantity of solvent. So this table shows the solubility guideline for common ionic compound in water, for soluble ionic compound and insoluble ionic compound. So all the nitrates, important exception none, all nitrates will be soluble, all acetate will be soluble. Chloride compound of silver, mercury and lead will not soluble. Bromides of mercury, silver and lead will not dissolve. Iodide and sulfate, iodide salt of silver, iodide salt of mercury and iodide salt of lead will also not dissolve in will not soluble in water. Same way sulfate of strontium, barium, mercury and lead will also not soluble. And insoluble, so sulfite, mostly everything will be insoluble, but there are some exception, that sulfide of ammonia and alkali metal cation, calcium, strontium and barium will not insoluble, so they will be dissolved. So we have to apply this solubility rules to the ionic compound whenever we do metathesis reaction or precipitation reaction. So let's just summarize this rule, that all nitrates are soluble, all acetates are soluble, all alkali metal salts are soluble, and all ammonium salts are soluble. Silver, mercury and lead salts are generally not soluble. On the other hand, halides is considered as a chlorine, bromine and iodine. So halide salts like chloride, bromide and iodide are generally soluble except mercury, lead and silver. So that is why this table is important to find out. Mostly these are soluble except mostly nitrate and acetate of all salts are soluble, but chloride, bromide and iodide and sulfate of these these metals are not soluble in water. On the other hand, all the sulfides will also be soluble except these. If the sulfide is with ammonium sulfide or calcium sulfide, they will not be soluble. Basically they will be soluble because this is an insoluble ionic compound. So these two slides are important for remembering which compound will be soluble and which not.